Alright, welcome back again. We've got another interesting build for you. It is getting more and more exciting as we go. And today's no exception. We're going to use a new part, which most of you are familiar with, and that is going to be joysticks. Now, this lesson, we're going to do something simple with joysticks, kind of just show you how they work, how we can write some code. It's not going to do anything spectacular. We're just going to kind of show you how the code interacts with the joystick and vice versa. But in later builds, we'll have the joystick doing something that's more exciting. This time around, I'll probably just have the joystick. I think we'll use a buzzer or something. Okay, well, let's flip screens. And let me show you the parts list is up here on Canvas. I am over here under the camera. We've got the joystick itself, and previous to this, if we wanted to get some input from the user, all we had was our potentiometer. We could turn the knob, and that was nice for some things. And with the joystick, of course, we can move it forward and backwards and left and right. And basically, just dropped it. Basically, this joystick is two potentiometers. We have, instead of turning it, we're pushing the joystick forward and backward in two axes of motion. So we have a potentiometer that we can go forward and back. Actually, we do it under here. I think you get the idea. By pushing it forward and backwards, that is one potentiometer in the y-axis, and then we can go left and right, and that is the second potentiometer in the x-axis. There's also a third thing we can do with this joystick, and that is if we press it down, it acts like a switch. So we're going to take a look at all three of those things one at a time, and then kind of combine them into a simple little build to show you how that works. So first off, we got a new part, some wires coming out of it. We got to figure out what goes where, right? This one is labeled nicely for us, for the most part. If you hold it just right, I can see the ground at the top, and I can see the 5 volts, the next wire. It looks like VRX for the next one, VRY, and then SW. As usual, if we're not sure what these are, we look them up. That's where I get my graphics from. I just type into Google and I get up something like this that you see here on Canvas, and it'll just show us where each wire goes. Now, VRX, VRY, and SW, these are analog digital pins. It doesn't matter which ones we use for this, as long as the VRX and VRY are analog pins. So instead of A0, we could use A5. Instead of A1, we could use A2 or A3 or whatever. And the SW is going to be that'll be our switch. So we have the two potentiometers, this one, and then our little button pressing it in. So we'll construct this probably. Let's wire this whole thing up, and then when we write our code, let's introduce each potentiometer one at a time, introduce the switch, and to slowly combine until we have the whole, we're getting data from everything. Alright, now notice on this one we have these protruding wires, and that is something new we haven't encountered. What we did with the LCD monitor, and we just took the whole thing and just pushed it into our breadboard. And before you do that, I'm going to explain something as I attempt to push it in here, and it's rather difficult. The problem with doing this is it's kind of awkward to use our joystick like this. Now it works, and I guess it's not that big of a pain, but normally you think of joystick and you have it in your hand and you can do something with it. Here it's kind of attached to the breadboard, and we like to untether it. I mean, if you don't have any other choice, we can do that, but we have a choice. I can take these special wires. The other wires, we had wires coming out both ends. These are a little different. We have one wire coming out this end and an opening on this other end. And so basically the one end can go on the other. Now here's a little loop we can make, but that's not what our intention is. We need to have this end so that we can push it in to one of these. So that's just like a normal wire we're used to. And these are called male to female wires. And let's go ahead and start wiring this up. So I need 5 of these. First one's the ground. I wonder if we need to use the ground rail or not, or if I can just go right in to the Arduino. I think we can go right into the Arduino. Let's go ahead and risk it here. So let's start this off again. These are a little loose, but once we get a few more in here, the pressure from the wire next to it should hold it in a little better. So here's our ground wire. Matter of fact, maybe we should just push our wires in first so that they aren't loose. No, let's do one at a time. That'll be easier for you. If they fall out, we'll deal with that. But so the first one's ground wire. Let's go over here, find our ground. The next one over, if we ever get lost, we can look over here on the canvas. And next one over is the 5 volt. I'm going to use this purple wire next to it. And that did get a little snug, which is what we want. We need the 5 volts. That is getting tiny for my eyeballs. So let me double check that I got in the right spot. I'm nearsighted, so I see better with my glasses off. Okay, so that is in the 5 volt one. So there we are, trying to make it so you can see what I've done. The ground 5 volt, ground 5 volt. We set out virtually with every single part we use. And let's use, I got a blue one here. Let's use the blue one. Let's put that one in. And we're going to use, let's go ahead and follow along exactly what they did in our table up here. We could pick anything from A0 to A5, but let's just go ahead and use A0. So over here we have the A0. I'm going to put in that one so it matches what we have in the table like that. And then let's actually pause and go ahead and do some code and see what we get out of just this much wiring. So let's go ahead and open up this. Get rid of some of these comments that always appear. We're going to want to see what we're doing. We need some feedback. So let's open up the serial monitor again. Kind of standard. And I need to type this right. Changes colors. Meaning it recognizes what that statement is. Let's see. We need to analog read. And we got to store it again. So let's not use ham sandwich this time like I did in the last video. Let's call it something that's a little more logical. Let's call it the V. No, let's call it what is this going to be? Let me look at the part again. It says VRX, but the X is the important part, the X axis. So let's call it the X X joystick, X variable. Let's call it X variable. I like that. And maybe go back to lowercase X variable. That's what we're going to store this value as. That looks pretty good. We're going to analog read this value, and it's A0. That's the wire. That's the pin we put that wire in. Let's go ahead and just take a peek and see what it looks like. We're going to compare how this looks with just a normal potentiometer. So serial.print. And let's be thorough here. Let's go ahead and do X variable equals is not capitals, lowercase. Mr. Brower, be careful. Oop, there we go. And let's do the next line where we put in. I'm usually doing this. I'm not talking to myself when I'm actually doing this stuff. So talking out loud sometimes throws me off. But no worries, we got it. Alright, so we're reading AO, we're going to store it, and then we're going to take a peek at it. That's all we're going to do for just this first part. Whoop, that's not the right side. And let's take a look and make sure it seems to be happy with that already. Let's go ahead and upload that. I probably should have done one more thing. I'm going to cancel this. Do a little delay, or the number is going to flash by us. Man, Mr. Brown cannot spell today. Let's go have a second. Now let's run this up. And I'm not worried about saving it. You can go ahead and save it if you'd like. A little waiting time again. We're going to be lucky to have it go fast or slow. Not too bad. Alright, let's open this up. There's our values. Ripping down the page, I'm going to take my joystick and go left and right. Why is it saying there's an error? Let's go ahead and proceed here, and that went to 0, and that goes to 1023. If I control, so that's our x-axis is in this orientation. So doing nothing, we're at 509. Over here I'm at 1023, and going up is 0. Now they call that the x-axis, but normally if I was probably actually using this, I'd probably have it like this. I probably want to change the name of my variables, but let's just go ahead and we'll hold it like this. So that's more like the x-axis. Alright, so that looks pretty good. Let's go ahead and do the same thing for the y-axis on our joystick. We'll do virtually the same thing. Actually, my mind is telling me there's something cool we could do with this. If we wanted to, we could, I think I showed you this before, but I'm not sure. I'm going to comment that stuff out. And there's another way we can look at the data without having to serial print the variable out. So let's just take a peek at that while it's on my mind. Instead of using the serial monitor, we're going to use the serial plotter. So come on, you can do it. Done uploading. So up here under tools, we're going to select serial plotter, and then it's blank. I don't know why it's blank. That's a little weird. Well, okay, Mr. Brower is being silly here. That's okay, we have mistakes. It makes me think. The reason why is because we're not sending any variable. They blocked out too much. Actually, that's the one I want to block out. That's the one I want to unblock out. I still got to send the variable to the serial monitor. I wiped out one line too many. I didn't need this one because I didn't want to have any text up there. I didn't really need to wait any longer. The plotter can handle fast speeds. But I cleared out the one that actually sends the information to the plotter. So let's try this one more time. I don't know if it was worth the time, but I think it's kind of cool. So let's go back to tools again. Go to our plotter. And there we go. Alright, so let's try this again. Down it goes. Back to that value, 500 or so. And then back up. And I can turn this like that, back and forth. So that's kind of neat. Now we get a little jiggle once in a while. That's just some noise. Alright, let's continue. Let's go and get rid of that and get rid of that for right now. Let's go back and hook up the y-axis. I'm going to use this gray wire. Get a little hard to push in there. And let's go ahead and use the value in our table here. We used A1, so I'm going to put it into A1. Slide over here so you can see what I'm doing. I'm going to go put it right into A1. Like that. We'll add a little bit of code. go back to this. Oop, it was up. Let's bring it open. We'll need a new variable for the y-axis. Let's call it y variable. Let's throw that in underneath here. So y variable, and we have to do an analog read. That is pin A1. Let's as well take a peek at it. You can probably already anticipate what's going to happen here. Whoop, did I not hit? What did I do? There we go. I have to switch this out though, because this is the y variable. This is the y variable. So now we're going to look at the A1, which is y-axis potentiometer. We're going to store it as y variable, and then we're going to print it out. So let's take a quick peek at that, and then we're going to add the pin, and then we'll make it do something interesting besides just looking at numbers on a monitor, because that's cool, diagnostic tool, but we want it to do something interesting. Since this is the first time we've seen a joystick though, I wanted to go a little slow, kind of show you how each part works. Alright, so we got both variables. This time I'm going to go up, and we jump to 1023. We're skipping some of the numbers in between. That is because we're collecting data every half second. If I go really slow, I can get those values. Yeah, I go really slow. If I don't like that, I can get rid of the delay, and then I can see them. I'm not jumping from 524 to 0. If I go really slow, I can get some of those values in between. Alright, so now I've got both potentiometers ready to go. Both axes are getting me the inputs I need. I kind of remember in my mind that doing nothing is around just over 500. And we max out at 1023, both, 0 for that one, 1023 that direction, 1023 that direction. So let's add, or should we do the button first? Should we add the button first? I say we add the button first. Let's see everything. And let's call it button this time, that makes sense. And this time around we have to do things slightly different. We're in a different pin. It's wired up. I'm going to use this black wire. It's the SW pin. The table suggests we do 8. We could do any of the digital pins, but I think it said 8, so let's just go with what we have on the table, so it's a little easier for you to follow along. Now we're on the digital pin side, pin 8. So we cannot do analog read. Analog read is for the analog pins. We're going to have to do some digital reading. So let's go ahead and do that. We got a variable to store it with. Let's jump down and push that down a little bit. I'm going to give a little space in between these, perhaps, so we can see what's happening a little better. And button is what we're storing it as. And we're going to do a digital read. If I can spell it right. Digital read, a different kind of pin, and we're in 8. We're in pin 8, so it's going to read that as button, and then we can just see what it says. I'm going to speed this up a little bit. We're going to grab these two lines. We're going to do a little copy, paste, and modify it a little bit. This is going to be button, and put button over here. Okay. Now, there is one more thing we have to do, and this is probably not going to make a whole lot of sense, but we're going to have to do it anyway. And we're going to have to do one line here, digital write, pin 8, hide. I'll explain what this does, but it's not going to make 100%. It's not going to make 100% sense, but we have to have it in there. So let's discuss briefly why we need to turn the pin 8 high. Why do we at the beginning do we have to turn pin 8, which is our button when we press this thing? Why do we have to set it high when we leave it alone? If we don't do that, we're going to run into a few problems. This is the digital write 8 high is a built-in pull-up resistor. Now I know I just said a bunch of nonsense, but basically, oddly enough, push button switches are more cumbersome than most parts we have in our kit. Most of the parts are pretty straightforward to use. Switches, push button switches are a pain. And I'll give you one reason for that, and I don't want to spend a whole lot of time on this, but basically the computer thinks super fast. And we kind of live in a slower universe. Our perceptions are slower. So when we push a button on something, and we think we're just pressing it in, and when we let go, we're done pressing it. But at the speed the computer sees it, when we're actually pushing that button in, it's going to vibrate for a moment, and it's going to be pressed and unpressed maybe 500 times in a half a second. And a half a second does mean is meaningless, but the computer, a half a second is, you can see all that. And all that is noise. It's going to be a problem. So long story short, we want to eliminate some of these button problems by setting it to high when we're not using it, and then we press and hold it in. Then we're going to read a different value, and we'll upload this and take a peek at what I mean by that. So let's go ahead and try this out. So right now it's digital write, it's going to read high, should read a 1. It's digital, so all we're going to get is zeros and ones with digital. The analog, we can get a lot of different numbers. So the reading of our button is going to be either on or off. And right now we turned it on. So when we press it, it should go off to 0. So let's take a peek. Alright, so we're forcing it to be on. We're looking at the button 1 part, because we told it to do that. Digital write, pin 8, be on. And when I press it, one of my wires came out. Yes, my wire came out. Get back in there, pin 8. So when I press it, now it reads 0. Let it go, or back to 1. If I don't put this line here, you can toy around with this if you'd like. This 1 and on-off state is going to flicker, is the best way to describe it. And so to get rid of that problem, we're going to just set it, we're going to force it to be high, then until we do something with it, then it'll jump to low. Alright, so we've got information about both axes, the x-axis on our joystick and the y-axis, and the button. We know it's all working. Everything's looking good. We took the time to do a serial print for every single variable. Normally in our code we wouldn't have to write all this stuff out. We could leave it all out. If we want, we can go back and get rid of it all. But let's have it do something interesting at the very end here. Let's get rid of the delay. And I mentioned that we'd throw in something simple like a buzzer. Let's go ahead and do that. So for our buzzer, let's say that when we operate our joystick and we push it to an extreme value, 1023, this way or up, or push the button, in either state, let's say the buzzer goes on. We'll have it beep. So I'm going to move over here, and I've got my buzzer. It's positive on one end, the plus, so I got to make sure this goes into a pin. That's going to give it useful information, and the other side is negative. So let's push that in here. And I need to peek and see how many spaces are in between the legs here. There is going to be 2 spaces. So this one will be way over here. And maybe I should flip that, because that's my positive side, and red's generally used for positive. And the other one is going to be for ground. So let's go ahead and take this one and move it into ground. I have an extra ground way up here. Oop, wrong one. Move it up one more to ground. And this is going to be my signal wire. And let's go ahead and use, I don't know, let's just pick one. Pin 2 sounds good. So I'm putting that one in pin 2. Alright, that's easy enough. I'll leave it there so you can see it. Alright, so we're going to do an if statement. Let's start with the button to check this out before we add a lot of variables again. So we want it to check. 2 equals means we're checking. 1 equal here means we're assigning something. So up here, if I say analog read AO equals X variable, I'm taking whatever I read and I'm assigning it to this bucket right here, right? Here I'm checking. I want to look. I want to say, all right, look and see what the value of the button is. If it's 0, then I want you to do something. And what we have it do is going to be in these brackets. And we just want the buzzer to go on. So let's go ahead and we got a couple ways to turn the buzzer on. We can flick it on and off, digital right, high, and low real fast. But we're going to use the tone one because it's just so much easier. And we choose the pin we're using, which is pin 2 for our buzzer, and then we need a frequency, which is I'm just gonna pick 3000 hertz. So let's also have it stay on for like 1 second. Let's give that a try. So when the button state is 0, we force it to be on when we're not using it. We have to press it for it to be 0, and then we should hear a tone from our buzzer. Alrighty, one more squeeze of the cat. Come on, compiler, you can do it. There it goes. Almost done uploading. Okay, let's grab the joystick and press it, and we hear the buzzer, and it's not turning off. It's driving me nuts. We got to fix this. Hold on, let's pull the ground wire out. I'd say that was deliberate, but that was not deliberate. That was me making an error, which is okay. When we're in here, it's turning it on, but then there's nothing that turns it off. Once we get out of the if statement, it's still going to stay on. So no worries, we can go ahead and do no tone for pin 2. Please turn off when you're done. So after we jump into this if loop, we have it on for a second, and we jump out, we're going to turn the thing back off. So while this is uploading, I'm going to replug the ground back in right there. The new code hasn't entered yet. We're still compiling the sketch, so I probably shouldn't have pushed that in yet. I'm going to go nuts here. Let's pull the ground pin out until it's done. And the new code is uploaded. Alright, now we're done. So I can put the ground wire back in. Let's give it a little test. Let's press the joystick. And it goes out after 1 second. Let's press it one more time. How about that? Let's do the same thing. One last little piece here. Let's go ahead and do the same thing for the x-axis variable on the joystick. Let's check and have it be, if it's 1023, then we're going to have it do the exact same thing. We're going to have it turn the buzzer on. Let's, for giggles, have it be a different pitch though. Let's do like 4000, and delay be on for 1 second. We could do shorter delay, but let's just go 1 second. So there's our little if statement for the x variable axis. Let's do one last one for the y variable axis. Gotta make sure V is capitalized. 1023 again. So it's going to check. Once it's 1023, then it'll jump into this little if part, and it's going to turn on the tone, pin 2, and let's go 5000 this time, and have it wait for 1 second. Easy enough. And then afterwards, I'm going to delete, just copy paste that and put that at the end. Although technically I don't think it's going to matter where it's at, because it's going to loop through this whole thing over and over again, but it feels nicer having it at the end. Once it comes out of that if statement, we're going to turn it off. Okay, so we got that for the y-axis variable, the x-axis when it reaches 1023, which is the maximum value, and the button on the joystick. So let's try all those out. Now, right now we're just controlling a simple buzzer, but we could control lots of other things with our joystick. I think you can imagine the other parts that we've used. Any of them require input. We could use a joystick as the input. Okay, so it says done uploading. We'll press it, the button again. It goes out. Let's try the x-axis. Oh, that one hurts. That one hurt my ear. And I guess, what did I say? Y-axis. That was a little better. Kind of cool, right? Now, if you have time, I'd recommend, maybe you could, little extension here. I'm having the tone go on when it's 1023, but you could use the full functionality of the joystick 0 to 1023 when I move it across like this. Perhaps you could have that control the tone that comes out that we hear. So the tone that we hear could be where our joystick is currently located. So if it's right over here, it's one pitch. If it's right here, it's another pitch. If it's way over here, it's another pitch. You could give that a try if you like. All right, otherwise we're done. It's kind of a long code, but if you notice, a bunch of this is just to make sure it works. If we actually got rid of a bunch of it and shrink it down, the parts that we actually need get smaller and smaller. And get rid of all that, get rid of some spaces, get rid of some more spaces. It actually folds down into a relatively tiny piece of code here. So, all right, good enough. That was a nice one. Oh, I bumped the table and we went out of focus there for a second. Okay, we will see you in the next project. Enjoy.